Good morning, I'm Angus at LabVac. Today something slightly different. I've got a diaphragm pump here from Ilmvac, which is now part of Welch Gardner Denver Group. We're going to get through this. This should be a short-ish video by my standards, because this is a very simple pump, relatively quick to service. I've put the pump up on its side. This is a dry running pump, there's no fluids to worry about in here. I'm going to start by undoing the knurled nuts and taking the connecting pipe out from between the two heads. So 2 heads, 8 millibar pump. Each head has 4 head bolts, which I'm going to wind out. Now, this being a simple pump and being a chemically resistant version of said pump, the heads on here are made from PTFE, which is a fluorinated plastic, which is very resistant to chemistry and fairly easy to clean. There goes our stainless steel plate. That's put on there just to spread the load of the 4 bolts to prevent the corners from being crushed down. I think you can just about see on here this has been tightened up quite a lot over the years, and has started to misshape. So there's a bit of a curve there. Underneath the outer head we have the inner head, again solid Teflon, and these are all parts that are going to need to be cleaned. And then we come to the diaphragm itself. The diaphragm is the blue part that you can see around the outside, which has mostly turned to black just from time working as a pump. In the centre of it we've got this strain washer which holds the diaphragm onto the connecting rod underneath, and to remove this you need this special tool which is called a pin face spanner. It has 2 small pins on the end of these adjustable arms, and there are corresponding recesses in the strain washer, so 1 pin goes into each hole, and then holding the tool tight you can just loosen it out from there. If the tool spills out of those 2 holes it will scratch the surface of this strain washer. The strain washer has been PTFE coated, so the black material here is the PTFE coating, much like a frying pan, and it's easily damaged. And you can see from this that just through normal work we have got some pitting and scratches through there. So I'm going to give that a quick clean up with a general purpose solvent. If you're in the lab, if you've got a wash bottle with acetone in it, that would be ideal for doing this sort of job. And you can see as we clean that up, we've got this shiny surface here which is the PTFE coating, and here it's worn where it's contacted inside the pump, caused some wear on there. It's not actually too bad at all, and that's going to get reused. But if your Teflon coating is completely damaged and lifted off, then you would need to buy a new replacement strain washer to go in there, but that's fine. Underneath there we've got the diaphragm. Behind that there is a backing plate which we need to take out now. Sometimes this whole assembly will come apart with the strain washer stuck to the diaphragm, and it'll come apart in one piece. Sometimes it'll come out separately like this. So I've just edged under the outside of the diaphragm, and I'm going to run my tool all the way around there to release the diaphragm. Very important at this point to lift this off carefully, because there may or may not be some very small shims underneath here on this assembly. So I'll turn that over. You can see that's the backing plate. I can peel the old diaphragm off there. throw it away. And then on the end of the connecting rod here is a shim, and these shims are put in at the factory to adjust the relative position of the strain washer and diaphragm against the head to achieve the best vacuum. Sometimes there won't be a shim, sometimes there'll be one, maybe two, possibly even three, depending on how the factory have set that up. And it's important to put back whatever comes out. So caution taking that off. If they do fall inside, you need to put a magnet in there and fish them out. And I'm just checking here that the connecting rod is firmly attached. There's no wobble in the bearing in there. This one's absolutely fine. So you can start the process of cleaning up these components. Strain washer I've done. The backing plate, you can see, has got a small amount of black material on there. That's just the backing from the diaphragm, which over time has adhered to the surface. I'm just using a bit of very fine Scotch-Brite pad to take that off. I want to get all the components as clean as possible without modifying the surfaces too much, changing any of the tolerances when the parts go back together. So quick clean up on that, and that's good to go back in. So here's our kit of parts for doing this. The kits, the diaphragm tool, any other replacement parts you might need, you can contact me for those parts. Be happy to supply them. So we've got various things in here, including 2 diaphragms, a set of 4 replacement valves, and a number of O-rings. Now these larger O-rings are the ones that go around the diaphragms. The smaller ones are for sealing external components. Some of these we might use, some of them we won't use at all. They'll cover various different pumps, so they may not all be necessary for your particular model. So the new diaphragm goes in there with the bluish face facing up. That's the PTFE membrane, and then on the back it's black nitrile, and those are sandwiched together, so the nitrile is there for strength but shouldn't be facing the wetted parts of the pump. The strain washer goes on the back, and then our shim, if I'm able to pick it up, will go back on behind there. Now you've got to get the whole assembly onto here without any of those parts falling off. So the easiest way to accomplish that is to turn the pump up onto its motor so that I now don't have to turn the diaphragm assembly upside down to get it on. It's very important to make sure that this strain washer bolt goes into the connecting rod correctly. The connecting rods are made of fairly soft aluminium, and it's very easy to cross thread these. If you do cross thread one, then the connecting rod will be trashed and that will have to come out and be replaced. That is a major job. I've done enough of them to know that it's worth putting the time into carefully fitting this and not causing the damage in the first place. So once that's wound in by hand, I like to do it like that so that I can feel if there are any problems as it goes in. If there are, if it binds, if it sticks, take it out. Wind it back out carefully and assess what has happened, whether there's debris in the thread or whether it's already cross-threaded. And then I'm just using the diaphragm tool here, holding it tight in so it doesn't scratch. And then I want to tighten that as much as I can by hand, and that's the diaphragm replaced. So now we can go ahead and build up the inner and outer heads. I need to start by taking out the old parts so the valve comes out very easily, and then you just want to tease these O-rings out of the grooves. They're going to get replaced as well. And again, take your time, be cautious, because if you do put any deep scratches into these surfaces, they're expensive parts to replace. Then I need to clean the valve seats. So I'll put a little bit of solvent on there. I'm starting off just with a soft cloth, and then I'm going to assess that and see whether I've got them clean enough. And I would say on that, yes, they look pretty good. If there's a lot of debris built up on there, then it might be necessary to use the Scotch-Brite pad again and very carefully go over the surfaces, not putting any pressure on, just let the pad do the work. The other thing that I want to do to make sure this is clean is I'm going to run a bottle brush, test tube brush, whatever you like to call it, in through that fitting, and I can actually see through these holes as it comes through, and just make sure that it's not moving any debris inside there. Now I can't do the same obviously over here because I've got an elbow fitting on there, but if one side is fairly clean, the other side should be as well. And I'm going to use a smaller brush to go through the small holes here again, looking for any debris that's moving around. If there is anything in there, then we'll need to take more action to clean it out, possibly remove the outer fittings to be able to get inside more easily. But this one is clean. I'm going to give it a blast of air. Down through both of those, again making sure that I don't see anything moving around or anything blowing out. So that's a clean part, ready to go back on. Now the inner surface here, this is where material tends to build up. So for this, I'm going to pick it up in my cloth, apply some solvent, and then I am going to use my very fine Scotch-Brite material just to run over there and loosen off anything. Again, I'm not putting a lot of pressure on here. I do not want to modify this surface. I just want to clean away whatever's stuck to it. So, wiping it down again and assessing where I've got to. And I can see there's still a fair build-up around here, particularly. So I'll just go back to that again with the Scotch-Brite pad and work specifically on that point and any other areas where I'm not seeing nice clean PTFE. Keep washing it down, going back. It's all got to be done by eye. There's no magic formula of do this, do that. You've really got to make judgment calls as you go on exactly how you tackle all of these things. See, I've still got build up around there that's not responding very well to the Scotch-Brite pad. So the next thing I'm going to do, just to get those loose, is take the outside of the very tip of my scribe, and with no pressure at all, just run over those areas where I've got a big build-up of material. I'm not putting any pressure on this, because this tool will scratch this surface very easily. So you've got to use judgment there and just do what's necessary to get the part clean without gouging into the material. And once that's done, you can just see here this shape here, which corresponds to the wear on the strain washer. Finish off with compressed air just to make sure that that's dry. Check it again. Keep checking it until I'm absolutely happy. And then I can reassemble that to the pump. Now, orientation matters. If you put this in the wrong way round, then your inlet becomes your outlet, and your outlet becomes your inlet. The pump will start to fight itself. So taking photos as you dismantle can help. But what we also have on this particular pump is a dowel pin mounted here, which should stay in place when it's taken apart. That obviously has to correspond with this hole. The fittings have to be on the face they were to start with, so I know that that's the correct orientation for my pump. So I can put new O-rings now into these grooves. These should sit tightly, so I should be able to turn this upside down without these falling out. These ones feel pretty loose, so there's another thing that I've got to deal with. Those won't stay in tight. The valves will go onto this surface. There are two very shallow wells for these to sit into, and the valves have a shiny side and a matte side. The shiny side is the sealing surface, and it seals against the centre hole. So I'm going to put that one shiny side down, and then this one I'm going to turn the other way up, because this is my non-sealing surface, and then when I fit the head on there, that will correspond, bring that together. Now I do have this issue that these O-rings don't stay tight in this head. They're just going to keep falling out. So there's various ways that you can counter that. The first one I'm going to try is to just slightly wet these, fit them in, and maybe I'll be lucky and the surface tension will hold that. Chemically resistant pumps, I'm just going to use some of the solvent there to provide a bit of tension and see if those will stay in, which they do. So that's the first approach, and it seems to be working. Now I need to lower this onto here with the dowel pin in the corresponding position, so that all goes together. If the dowel pin's off, then the head will be cocked over in one direction or another. So if you've got an equal gap all the way round, then you know it's engaged properly. And don't forget to put the steel plate back on to spread the load, and then the head bolts drop back in like that. Now tightening here, I'm just bringing these bolts down until they snug against the plate. I'm going to do that all the way round without tightening any of them, just to take up the load. Then I'll go back round again, and at this stage I don't want to put a lot of tension on these bolts. When the pump goes across for testing, it's going to be run for a good long time, several hours, and then as a final adjustment that I can make, I can tighten or indeed loosen any of these bolts in order to bring it into good vacuum. So to start with, I'm just making sure that those are snugged. Of course, each time I tighten one of them, it'll leave one loose. So I'm just working around repeatedly until they all stay snug, which they do. That's that side of the pump done. Flip it over, slot that up underneath there, and then I can repeat the process on the other side. Just removing that label that the customer has put on there. Don't particularly want to show you whose pump I'm working on. So this is now a direct repeat of what we did before, just for the second head. And everything should be pretty much the same inside of here. If you've got a head like this that's very stuck on, you can just slide a flat blade screwdriver in the gap that remains in between and use that to gently lift it, gently. If you go hard at that and the thing suddenly moves, you might end up scratching and damaging surfaces. This one is quite a bit more stuck together. There is also a groove machined all the way around the inner head, which is designed for you to get your flat blade in there. If the two heads are stuck together, you can see that just pops them apart quite easily. And again, seeing all the same stuff in here. All these replaceable parts need to come out. This will go through exactly the same process. It's just going to take a little bit more work because the condition in here is not quite so good. So this is quite common. This has all come off as one piece and it's very stuck together. It's not coming apart easily. When that happens, again, flat blade screwdriver in here and then pry against the rubber so that the tip of the screwdriver is going into the rubber, because you're going to be replacing that anyway. So if you do any damage to the rubber, no consequence. If you pry in the opposite direction and scratch this surface, then obviously you've then got more work to do to make that good. So if you come to this point and you find your diaphragm is crinkled up like this, that's not ideal. We want it to lie flat when we put the head onto it. What I'm going to do is just take a tool and go in through the fan cover, just push the fan round a few times. Very careful not to snap any of the plastic parts back here. Hopefully what will happen is I'll be able to get enough of a turn on there to release the position of the diaphragm so that it sits up, and then I can re-flatten the diaphragm so it's sitting in a good position ready for rebuild. Then back to cleaning. Okay, so I've made everything as clean as I think it needs to be. The remaining parts. That head, no problem. Those O-rings are going to stay in place for me. So again, checking the orientation as this goes back together. Checking that everything is clear. I've been using compressed air, so I'm bound to blow some parts, little bits of dust and so on around, so just rechecking for those. Insert the valves. And refit the head. And as those go back together, just a reminder that if you're finding these videos useful, please like and subscribe to the channel so that I can keep making them, because if nobody seems to be liking them, I'll give up. Also, the parts and tools that you see being used, you can contact us for any of those that you need for this or any other type of pump that you've got. So with that done, the last thing to do is just run a brush through the connecting pipe. This looks clean to me. I'm going to run that through, just see if anything gets dragged out. That suggests I need to be more thorough. I think we're good there. So that goes back on between the two heads. Just keep the pipe over, curve it over to get it in the remaining way. Then take it apart again to get your glove out. I'm not a fan of wearing gloves, particularly with these types of pumps that are used in chemistry environments. You really do need to play safe. These fittings only need to be finger tight. The flats that are on there are for getting them undone, not for doing them up. They really do only need to be finger tight. And then that's the pump done. That'll go over to the bench. Like I say, that's going to run for a good few hours before I worry too much about final vacuum. If I start it up and I've got 100 millibar, then I'll switch it off and bring it back because something is fundamentally wrong. If I've got 20 or 30 millibar, then that's fine. I'm just going to let it run, let all those new parts bed in. Diaphragm pumps take a long time to bed in. In fact, when these were made in the factory, they would run for 24 hours before they went to final test. So 3 or 4 hours is probably suitable after a service. Thank you.